Hello all, welcome to Gurukul CAT 100 series, a series designed to take you from your study room to your corporate boardroom. I am Deepak and this is Daily Quant with Deepak. Hey all, welcome back to day 32 of 100 days to CAT Quant series. In this video, we'll be discussing 5 questions from number system. So whenever a question is displayed on the screen, pause the video, try solving that question. Once you're done solving, you can resume the video. If you find this video useful, like the video, share this video with your friends who are preparing for CAT, and most importantly, for more videos of this kind, subscribe to this channel. Now, without any further delay, let's get started with the first question. Now coming to the first question, all possible pairs of distinct numbers A and B such that A is greater than B, A should be strictly greater than B, are chosen from a set of the first 30 natural numbers. So from 1 to 30. How many of these pairs are such that A square minus B square is divisible by 3? Now I will be writing A square minus B square as A minus B into A plus B. Now for this to be divisible by 3, either you can have A minus B multiple of 3, A plus B multiple of 3, or both A minus B and A plus B can be multiple of 3's. Right. Now let me consider the third case when A minus B and A plus B both are multiples of 3. Now how many multiples of 3 do we have from 1 to 30? You have 10 multiples of 3. Now, for both A minus B and A plus B to be multiple of 3's, both A and B should be multiples of 3. Right? So, both of them should be multiples of 3. Now, we have 10 multiples of 3. From those 10 multiples, you need to select 2. So, you have 10C2 base. Right? Now, let the two numbers be 18 and 24. Right, so I have selected two numbers from those 10 multiples. Let the numbers be 18 and 24. Now my question to you is, can the value of A be 18? Is this possible? No. Right, because it is mentioned that A is greater than B. So in this selection, A has to be 24 and B should be 18. So for every selection, we have one ordered pair for A and B, right? So A is 24, B should be 18, right? If I consider 6 and 12, then A has to be 6 and A has to be 12 and B has to be 6 and so on, right? So for every selection, we have one ordered pair. For 10 C2 selections, we'll have 10 C2 into 1, 10 C2 ordered pairs. Now coming to second case, where A plus B can be a multiple of 3. Now, when can this be multiple of 3? Now, if I consider A to be a number which leaves a remainder of 2 when divided by 3, then B should be a number which leaves remainder of 1 when divided by 3. Right? For example, if I consider A to be 3x plus 2 and B to be 3x plus 1. Now, or 3y plus 1. Now, what do we have? 3x plus 3y plus 3, a multiple of 3. Right. So, if this is a number which leaves a remainder 2 when divided by 3, then B should be a number which leaves a remainder of 1 when divided by 3, and vice versa. If this is a number which leaves a remainder of 1 when divided by 3, then B should be a number which leaves a remainder of 2 when divided by 3. Right. Now, how many numbers do we have which leaves a remainder of 2 when divided by 3? Among the first 30 natural numbers, you have 10. Similarly, you have 10 numbers which will leave a remainder of 1 when divided by 3. Right? So, we are done with when A plus B is a multiple of 3. Now, similarly, for A minus B to be a multiple of 3, if A is a number which leaves a remainder of 2 when divided by 3, then B should also be a number which leaves a remainder of 2 when divided by 3. For example, if A is in the form of 3x plus 2 and B is in the form of 3y plus 2, then what do we have? 3x minus 3y, which is a multiple of 3, right? And similarly, if this is in the form of 3x plus 1, right, then B should also be in the form of 3y plus 1. That means both the numbers should leave a remainder of 1 when divided by 3, right? Now we have 20 such numbers, 10 which leaves the remainder of 2 when divided by 3, and 10 numbers which leaves the remainder of 1 when divided by 3. Now let me consider a number which leaves a remainder of 2 when divided by 3, right? Now, if we have a number which leaves a remainder of 1 when divided by 3, then the sum of these two, a plus b, will be multiple of 3. And if we take another number which leaves a remainder of 2 when divided by 3, then a minus b, right? This will be multiple of 3, right? So you take any two out of these 20 numbers, either a plus b, sum of those two will be multiple of 3, or difference of 2 will be multiple of 3. So what should I do is we need to select two numbers from those 20. And for every selection, there is one ordered pair because it is mentioned that A is greater than B. So 20C2 plus 10C2. Now what is 20C2? 20 into 19 by 2, 190 plus 10C2, 45. 190 plus 45, 235. Hence option C should be the answer to this question. Now coming to the second question, M is a set of odd numbers with an even digit in hundreds place and an odd digits in tens and units place. All elements of M are divisible by 3. M contains how many elements that lie between 100 and 400? So we are talking about numbers from 101 to 399. So 3-digit numbers, right? Such that the first digit has to be even. So this should be 2 and remaining 2 digits should be odd, right? And we are asked to find the number of numbers that are divisible by 3. Now, what is the divisibility rule of 3? Sum of all the 3 digits should be divisible by 3, right? So, odd plus odd, even, even plus 2, even. So, this should be an even multiple of 3, and that should be 2 less than a multiple of 3. For example, if I consider the sum of these two as 4, 2 plus 4 is 6, right? Now, let me write 4 as a sum of two numbers which are odd. So, I can do that in two ways, 1, 3 or 3, 1. So, you have 2, 1, 3 and 2, 3, 1. We have two numbers plus 2, and if the sum of these two numbers, what is the next even multiple of 3? 12, right? Now, let me consider the sum of these two numbers as 10. Now, how can we have these two numbers and they have to be odd? So that can be 1 9, 9 1, 3 7, 7 3, 5 5. Right. So you have 5 numbers plus 5 plus 2 and 2 digits. Now what is the next even multiple of 3? We are done with 6, we are done with 12. The next one should be 18. Now 18 minus 2, 16. So sum of these two numbers should be 16. So what should these numbers be? 7 9 or 9 7. So you have two more, right? Now what is the next even multiple of 3? 24, right? Now what is 24 minus 2? 22. Now can we have sum of two digits as 22? No. So the maximum sum is 18 when the digits are 9 and 9. Alright, so we have how many such numbers? We have 2 plus 5, 7, 7 plus 2, 9. Hence, option C should be the answer to this question. Now, coming to the third question, find the remainder when 7 power 99 is divided by 2400. Now, whenever you come across these types of questions, now you need to check if we have any number in the form of 7 power x close to 2400. And we know that 49 square is 2401. Now, how can I write 49 square? 7 square whole square, right? So 7 power 4 is 2401, right? Now what is the multiple of 4 closest to 99? 96. Now let me write this as 7 power 96 into 7 cube by 2400. So I'll write this as 7 cube into 7 power 96 can be written as 7 power 4 power 24 divided by 2400. Now 7 power 4 is 2401 and divided by 2400 the remainder is 1. Now 7 cube is 343. So 343 into 1. So the answer for this question should be option B. Now coming to the fourth question. How many whole numbers between 100 and 800 contain the digit 2? Please be careful. We are not asked to find the number of times digit 2 has appeared between the numbers 100 and 800. No, we are asked to find the number of numbers that contain 2 as one of the digits. Right. Now we have numbers from 101 to 799. Now let me break this as 101 to 199, 200 to 299, then 300 to 399, 400 to 499, 500 to 599, 600 to 699, and 700 to 799. Now 101 to 199, you have 19 numbers having 2 as one of its digits. Right. Now from 200 to 299, you have 100 numbers having 2 as one of the digits. But we are not counting the number of 2's. Right. When you write numbers from 101 to 199 in a serial order. No, we are finding the number of numbers that have 2 as one of the digits. Right. Now from 300 to 399, you have 19 numbers, 19, 19, 19, and 19. So what? 1, 2, 3, 4, 5, 6. 19 into 6. 60 plus 54. 114 plus 100. So 214 should be the answer for this question. Hence option B. Now coming to the last question. A 3-digit number when multiplied by 2 gives a 4-digit number with at least one digit as 2. How many such 3-digit numbers are possible? Right. So a 3-digit number when multiplied by 2 should give us a 4-digit number. Right. So the minimum number is 500. So 500 into 2 you have 1000. And maximum number is 999 into 2. That is 1998. Okay, so how many numbers are there from 500 to 999? You have 500 numbers, right? Now out of these 500 numbers, and all these 500 are even numbers, right? So all these are even. So something into 2 cannot be odd. So we should be considering even numbers from 1000 to 1998. Okay, now let us find the number of numbers that does not have 2 as one of the digits. Now we know that the thousandth digit is 1, right? This has to be an even number, right? But let's exclude 2. So this could be either 0 or 4 or 6 or 8. So you have 4 possible digits, right? Now coming to this digit, right? So we have from 0 to 9, you can put any digit except for 2. So you have 9 digits to place here, and similarly 9 digits to place here because repetition can be allowed, right? So the total number of ways would be 9 into 9 into 4. So 81, 81 into 4. So you have 324 numbers that do not have 2 as any of its digits, right? So from these 500, we need to subtract these 324 numbers. So the answer for this question becomes 176. So you have 176 numbers when multiplied by 2 that results in a 4-digit number which has 2 as one of the digits.
Hope you enjoyed learning from today's session.
This series is designed to help you with your CAT preparation and practice daily. We are with you in this journey.
To watch the next video, click here. And to watch Gurukul's CAT 100 series, study room to boardroom, the entire playlist, click here.
If you learned from today's session, like, share, and subscribe.